So shall I start?
Yeah, please.
I'm sorry. Shall I start?
Yes, Pranav, you can go ahead.
Yeah. Okay.
Yeah.
Okay. Hi everyone. Welcome to this our monthly talk on Ascent, which is a platform meant to understand parallels between science and spirituality. So today's talk is going to be on abstractness. So what is this abstractness? So let's try to understand that first. So I'm going to start off with something many people are very familiar about, algebra. So it's a topic that we have been studying right since, I don't know, fourth standard. So fourth standard kids are here. So if they know something about algebra, that's good. So let's start off with some very elementary mathematics. So addition. So let's say you're a kid and you come across these numbers and you know what addition is. So you see that 1 and 0 added together is the number 1. And you come across two other numbers, half. It's a fraction. So half and another half when added gives 1. Then you come across these negative numbers and you say, okay, 2 and a negative 1 when added together also gives me 1. So now you're curious. You want to know what are the numbers that gives 1. As when you take two numbers and when you add them together, you want to know which number gives you a sum total of 1. So now you're curious. So you start thinking of all these other numbers. So 3 and minus 2, 4 and minus 3, or quarter and a 3/4, and so on and so on and so on. So now you realize that there are infinite numbers that satisfy this property of addition, where you take two numbers, add them together, and then you get 1. So then what do? So you can't list all of the infinite numbers out. So you try and figure out a way of understanding how that addition itself works for these infinite properties of numbers. And you say, okay, I'm going to use a variable called x, and I'm going to use another variable called y to represent these two numbers. So I'm not going to list out all the infinite possibilities. I'm just going to use a representative variable, a representative number called x and a representative number called y. And the property of these two numbers is such that when x and y are added, it gives me 1. So this is the foundation of algebra, where you use a representative quantity to identify with your numbers, and they start following some rules to give you what is the desired result. For example, over here, x is one number, y is another number, and when you add x and y, you get 1. So that is the rule. And all the numbers x comma y that satisfy this property are the numbers that belong to this class of addition. So another very nice, neat way to look at it is if you start graphing this. So this is where algebra and geometry are also connected, in the sense that you can visualize these numbers along two number lines, one going horizontally called x and the other going vertically called y. And all the numbers that satisfy this property fall on this slanted line over here, which follows the principle x plus y is equal to 1. So here what you have actually done is you have gone from the realm of knowing what numbers are to kind of having a substitute for the numbers in itself. And whenever you want to know about which number satisfy these properties, you can just bring about these numbers back into this master equation, which is x plus y is equal to 1. So this is the beauty of this algebra, where you can substitute all of these infinite numbers and try to understand that with just one very simple equation. So this is how algebra works. So another simple example is this thing where we are being grilled to understand, not understand, more likely grilled to memorize it. A plus b whole square is a square plus 2ab plus b square. We are grilled and grilled to memorize it because all the numbers satisfy this property. So uh, how do we visualize it though? So you can visualize it in the simple form of a square, where the length of one side is a and the other side is b, and then you make up this bigger square which is a plus b, and the area of each square goes as the square of the length. So a plus b, the whole square is this a square plus b square and two AB triangles. So what I want to say over here is that this A and B are substitutes again for these numbers, and all the properties, for example, 5 square is equal to 2 square plus 2 times 3 times 2 plus 3 square, right? So and you can have this infinite set of numbers, but all of those numbers that satisfy this property can be grouped into this one single small equation that you have. And this again, like I want to stress out, is the beauty of algebra, where this infinite set of numbers is being represented by some other variable in its sense. So this is what I call as abstraction, where seemingly unrelated symbols, for example numbers and letters, are being related together in a way where you try to understand an infinite set of numbers through a simple equation. So that is math. Another place where you see universality like this is in physics, where you try to understand how different things work, and you want to understand each of their movements, each of their motion in a very simple way, where you just have to substitute something, just like how you substitute numbers of math into that simple equation. You want to find a way where if I were to move this pen, or if I were to move this mouse, is there some simple way of understanding it? Is there some generalization there using which I can simply understand how a pen moves, or let's say how a mouse moves? So Newton's laws is something that generalizes a lot of things. For example, Newton's law of gravitation is universal in the sense that the way Earth moves around the sun, or the way Jupiter moves around the sun, or the way the moon moves around the Earth is all the same and can be defined by using just this one simple equation of gravity. F is gm1 m2 over r square, but that's the law of gravitation. So you can use this simple law of gravity to understand a lot of things, like how the Earth moves around the sun, or how the sun moves around the galaxy, and all this other stuff comes up. Another simple example is Newton's laws of motion. So how do bodies move when acted upon by a force? It's universal. Be it a pen, or be it a mouse, or be it a computer, all of them follow a simple rule, where all you have to do is substitute just one number for the pen, and one number for the mouse, and one number for the computer, instead of looking at how it moves every time around. So this is how abstraction kind of works in physics as well. So now with these two simple examples, I hope we can try to get a definition of what abstraction is. So to me, abstraction is the ability to theorize. So you see you see some experiment, you see another experiment. Now what happens if I did an experiment in the middle? For example, you drive your car at 40 kilometers per hour. You drive your car at 50 kilometers per hour. Is there a way in which you can drive your car at 45 kilometers per hour, somewhere between 40 and 50? All you do is you, instead of putting more pressure on the accelerator, you put little bit more pressure on the accelerator than what it is for 40 and little bit less than what it is for 50, right? So this ability to theorize, ability to find connection between two experiments for something that is not visually seen in the present, but could be possible. So this ability to theorize is abstractness. And another way to look at it is the ability to generalize. So you see something at 40, you see something at 50, and then is there something at 45? You say whatever happens at 40, whatever happens at 50, the physics is going to be the same, but all I'm going to do is change one number. For example, in that in the algebra case where x plus y was equal to 1, I'm going to say x was 1, y is 0 is one case, quarter and 3/4 is another case. Now I'm assuming the same laws of addition holds for the numbers 1/2 and 1/2 as well. So this ability to generalize the property of addition and to theorize it for numbers and to theorize it for experiments that don't exist yet, or for observations that has not been seen yet, is abstraction. So this is how I'm defining abstraction. Okay, so now being a physicist, what kind of abstractions do physicists deals with? So first we saw how simple algebra leads to so much abstraction, how simple laws of Newton leads to so much abstraction. Now complicated laws of a physicist leads to abstractions that are so abstract that people don't know what they're working at all. So let me just quickly go through this. So you see over here, there is a bottle. So people usually see a bottle, you say, okay, it's color blue, and so it's made of plastic and so on. What many physicists see is it's made of atoms. So all of these things are made up of these small tiny elements called atoms, and there's no way to visualize it because they're very small. There's no way to see it, there's no way to touch it, but we know they're made up of atoms. And now physics has gone to such an extent where you have broken even the nucleus in the center, which is made up of protons and neutrons, and you say, no, it's made up of something smaller called as quarks and gluons, and so on and so forth. So it's always going smaller and smaller and smaller into things. But the beauty of it is that all of these objects you can't see, you can't touch, you can't smell, you don't do anything about it. So we believe these things exist because some experiment indicated to it. Some needle moved, some experiment indicated that these things are there. You don't see it, you don't touch it, you don't feel it, you don't sense it in any way. You get all of these understanding through some indirect means. So now, how do I know that an electron exists? Well, I can measure these properties of an electron. So charge, mass, spin, and so on and so forth. There are many properties of an electron. And how do I know an electron exists? Because I measure one of these indirect parameters, and that is how I say an electron exists. So physics has now come into such a point where there is so much abstraction that all you end up with is an idea of something, an idea of an electron, an idea of a proton, an idea of a charge, an idea of a mass, rather than what actually it is. So there's so much indirect evidence that all you are convinced is that all physicists are convinced about right now is the idea of an electron, an idea of a proton, rather than what actually an electron is or what actually a proton is. So this is how deep an abstraction can lead to. So I just want to bring about this quick quote by this famous scientist called Schrodinger. So Schrodinger is one of the foundational fathers of quantum mechanics, which is a very widely accepted, one of the most successful theories as of today. So what Schrodinger said, so Schrodinger was very inspired by Eastern philosophy. And because he found a lot of connections with what Vedanta said and what he understood to be of quantum mechanics at that point of time. But one of his quotes is this: so the world extended in space, oh, I forgot. So the world, sorry. So the world extended in space and time is but our representation.
But our internal representation, I guess.
Yeah. So exactly. Yeah. So since all we are left is with these ideas of what things are, so we don't know what an electron is. All we have is the idea of an electron. So similarly, what we know is an idea of space, an idea of time. So this entire world, so Schrodinger says the entire world extended in space and time is nothing but a representation. So that is how deep abstractness can be driven into a person. So that being said, so again, why abstractness? So all of this idea of, like going deeper and getting more and more abstract. So why do we have to do this? Well, it's simple because it's the easy way of looking at truth. So if I want to know how two numbers add, I don't want to end up verifying it for all the infinite numbers. I know 1 and 0 works. I know a quarter and a 3/4 works. I know a half and a half works. So does it hold for 2 and -1 is the question. Well, I don't, every time I want to know how if that property is satisfied for these numbers, I don't want to do that process of addition again. Instead, all I want to do is I want to see if it fits onto that graphical line over there. So that is a much easier way to understand if those two numbers satisfy that property, right? So abstractness in a way generalizes things, and because of that generalization, it is an easy way of looking at truth. So what we see over here is a jug of water, but truly what is it? Well, you say it's made up of molecules called water, called H2O, sorry. And then the properties of water are coming up because of these hydrogen bonds in water and so on and so forth. And you say, okay, water in the river and water in the pond and water in the lake, water you drink, everything is going to be the same. There's not going to be so much difference. It's going to flow all the time and stuff. And so every time I want to see if the water in the lake has similar properties than the water in the ocean, I don't have to, because I just say, yes, they're all made up of H2O. So it's a kind of an easy way of looking at truth. So another simple example that I already discussed is this algebraic number line over here. So every time I want to know if two numbers satisfy this property, I don't have to go back to the math again and verify that it's one. Instead, I can just say, yeah, it's just there on the line. So now if you see outwardly, there seems to be no connection between numbers, algebra, or the line. But we have gone in, we have tried to understand all of these properties together and found out a way to connect a line to alphabets to the numbers and say they all mean the same, they all represent the same. So this is the success of abstractness. In the way seemingly disconnected things are somehow being connected in a very nice and neat way, and has also improved our ability to understand things and generalize it in a very nice, neat way. So this is why we need abstractness. So now coming after all the science, so what happens in Vedanta, according to me, is Vedanta is the biggest abstractness. And why is that? Because it says world is Maya. So now coming to such kind of a statement where you say the entire world is Maya is for me like the biggest abstractness that there can be. Because, okay, so here you see our famous scientist who's thinking about the world. And then there is this other person, Shankaracharya, who's calm and he says, why the world itself doesn't exist? Why do I
All
have to care about it? He's
It is
rooted the,
world is not
sorry?
Maya, it's not abstraction. Maya is the abstraction is the Maya.
Right.
The other way.
Yes. So, yes. So So abstraction is Maya. So, what is happening is the statement is the biggest generalization. Like I said, since abstractness is generalization, this statement that concludes that anything that changes doesn't exist is the biggest generalization. So in that way, Vedanta is the biggest abstractness according to me. So how does this so how does being in science help better to understand this this statement that anything that changes doesn't exist? So like I said before, science as sadhana has been a running theme, and what you develop in science is you develop curiosity to ask deeper questions, and you develop a passion to run behind a truth in a very incessant way. So what in general happens is so the greater the generalization you have, the greater the understanding needed. For example, in the algebra example, all you had to generalize was this system of numbers and addition. But when we go to science, when we go to physics, trying to find a connection at the atomic level is much more requires a much more greater understanding, simply because it's not something that now you can touch or feel. It's something that you have probed deeper, and you have rejected the traditional ideas of what senses are at that stage, and you have given yourself up to a greater understanding of a greater understanding of things that are not tangible anymore, but connected through an intangible way. So now, at the greatest abstraction of science, you have gone from tangible things to intangible things. But in Vedanta, you have gone from tangible and intangible to something that is not tangible at all. So this is the next level of abstraction. So how does science help is in cultivating the process of going towards of tangible to intangible, and intangible to not tangible, not tangible at all. So that is where I feel it helps, because since I said the greater the generalization, the greater the understanding needed, and what it needs is a very refined intellect to understand deep secrets of the universe. So that is how cultivation in science helps to understand abstractness better. So finally, I like to conclude with this. So this is what people nowadays call modern art. So what has happened here is art, which was before all about beauty and how you paint, and beauty in trying out in capturing realism of things, has gone to abstract works where you don't care about the paint anymore. You don't care about the painting anymore. For example, this one is just a black, it's just a canvas with black paint on it. There's nothing else. Like a 4-year-old kid could do it probably, but that is not the point of the art. The point of the art has gone beyond the traditional things of capturing realism, capturing the color, contrast, paint, and so on, into what it abstractly represents. For example, this painting's abstraction is that it's a new pigment that has not been seen before, and the black is so black that it's able to absorb a lot of light. So it's something like that. I'm not quite sure, but you get the idea behind it. It's gone beyond the traditional ideas of what paintings are, it's gone beyond the traditional ideas of a painting itself to something totally abstract, what is behind the painting. So I finally conclude with this statement. So we should be like a modern art, where we have to go beyond the traditional ideas of what tangibles are and intangibles are to something beyond it. Thank you.
Wonderful, Pranav. Beautiful explanation. Very nice. It's very, you explained abstraction in a very simple way. Even layman like us can understand. Good. So yeah, you can remove that this thing. I think slideshow you can remove.
Yes.
Slideshow is still on.
I removed. Oh, I thought I removed it. Okay. Do you want me to stop sharing?
Yeah, you can stop sharing.
Okay. Yes.
Yeah. A very nice idea of a very wonderful concept of abstraction, science and spirituality.
Yes.
Now, every living being lives in abstraction only, right? Because what is out there, we don't know.
Yes.
Right? Whether it's an ant or elephant, everybody operates on abstraction.
Yes.
Right? Because what is out there is energy, which we don't know what it is there. So whether it's a scientist or any living being, survival is abstraction only.
Yes.
Right?
Yes.
So what makes science is or any living organism is living based on organism. So what I call a science or spirituality is probably manipulate that abstraction, or rather process that abstraction.
Okay. Yeah. Sure.
Understand abstraction is abstraction, whereas all living beings live abstraction as reality.
Yes. Yes. All living beings conclude that whatever abstraction they understand is the real thing. So, for example, what we finally understand is an idea of an electron, but we think it is the electron.
Correct. That is the Maya for scientists.
Yes, agreed.
Right. So we have two categories. One is we operate on abstractions. Every living being does that.
Yes.
Okay, but for that living being, that abstraction is reality.
Yes.
Even for human beings, whatever abstraction is the reality. That abstraction which becomes reality is called Maya. Okay, when what you consider reality, you understand as abstraction, not real, then becomes liberation.
Yes.
Right?
Sure. Yes.
So I would say abstraction itself is Maya.
Okay.
Taking abstraction as real is Maya.
Yes.
Right.
Yes. So abstract. So there for me there are two things. So when you say abstraction is real, for me what you can say is all that exists is abstraction. All that exists is real. But when you say abstraction is real, then there's a problem.
There's a problem. That's what we call as Maya.
Yes. Sure. Yeah.
Right.
Yeah.
So now all that exists is abstraction.
Yes.
Okay. So in that sense, we are living in a world of, V means that even V is abstraction.
Yes.
So, and abstraction is nothing but an idea. Abstraction is an idea.
Yes.
Right? So at the fundamental level, everything is an idea, including abstraction and idea.
Yes.
And idea can be a unmanifest form, potential form, or manifest form.
What do you mean by potential, manifest, and unmanifest?
So when I say I have an abstraction,
yes,
the abstraction should be available for my perception in some way.
Okay.
Then only abstraction is possible.
Okay. So available to you and not available to you.
So
Okay.
for example, anything in science, when you apply logic,
yeah,
right, it should be, the abstraction should be available for intellect to grasp.
Yes.
Which means it's an idea.
Yes.
Right? So the moment it becomes an idea, it is manifest.
Okay.
So everything in the universe is nothing but idea in an unmanifest form. Once you give attention, it becomes manifest. It becomes abstraction for operation.
Okay.
Right?
Yeah.
So our consciousness is nothing but ideas which will be structured as abstraction for operation. Functioning.
Okay.
What you call as consciousness is nothing but ideas in potential form.
Okay. Sure.
Right?
Yes.
So got an idea for abstraction.
So I thought God is the biggest abstraction.
God is the biggest distraction. I understand. Abstraction, I don't know. It's a big distraction.
Yeah. Because you try to find, like in algebra, you try to find X, you try to find God, only to find that there is nothing specific like God. Everything else is. Everything all existence is. So,
yeah.
But all religions, of course, begin with this abstraction that there is a God. Yeah.
Yeah.
So, in a way, can we say, Prabhuji, that the whole sadhana is to break abstraction?
Abstraction is a distraction.
Abstract.
Get out of abstraction so that you are free from distraction is called sadhana.
Yeah, but abstraction is a way, considered a way to really realize reality.
No, it's neti. All
Science had taken this, and even Shankaracharya has taken this approach that using abstraction, they want to get to reality.
No, what Shankaracharya says is abstraction is the distraction. So get out of abstraction by saying neti. What you have to reject, he'll give some abstraction. But ultimately, all abstractions have to be removed, including the idea of abstraction.
Okay.
Yeah. So in reality, abstraction is the distraction. Abstraction is the Maya. And taking abstraction as real is the Maya.
So any limiting naming or is abstraction.
Correct. And all living beings are living in abstraction only. Any living, including ant.
Okay.
Elephant, right?
Yeah.
Abstraction is not a special ability of human beings. Of course, abstraction, human beings have higher level of abstraction, but all life is abstraction only in that sense.
Okay, that's true. So coming to science part, Pranav, we are right now observe that a lot of these experiments, which were earlier in the physical form with something measurable, now science is going more and more into what they call mental experiments, right? Thought experiments, right? Now, with thought experiments, see, with physical experiments, there is something that everybody else can agree, because there is finally a perceptive reality to come together. But
Mhm.
as we are going ahead, now this thought experiments are depending on so many levels of abstractions. Is it feasible for science to go ahead like this and achieve something which is agreeable for all?
I guess that is not the point of science. So, for example, I mean, the point of science is that you finally come to a common conclusion. So, the one of the backbone of science is that it has to be agreeable by a scientific, by a community. So, for example, Earth moves around the sun. Now I can come up with a theory where I say, no, it's not gravitation that is doing it. I have an invisible thread which can't be probed using light, which can't be probed using any of the techniques that I know for now. But I say there's an invisible thread, and that is how the Earth is moving around the sun. It's a perfectly valid theory because it explains why the Earth is moving around the sun. But there's no way for me to probe this thread. There's no way for me to say that this thread exists. So then it will lose. So that particular theory
But
will
even
lose
gravitation,
ground.
I can argue, for example, that even
Yes.
that gravitation, which we all have learned, is
Yes.
finally a set of mathematical models.
Yeah.
Right, and there is no reality as such other than the ability to apply it to the seen physical points, right?
Yes.
So there's a reality, there are some physical points, there's some correlation between the reality and the physical aspects, and then we say, okay, therefore this mathematics works.
Yes.
And
So
several times we know that mathematics doesn't work. We introduce new mathematics, like hundreds of new mathematics that is coming in, only to make it work. Correct?
Yes. Yes. So the subjectivity, so you yourself said it. So the subjectivity in the statement is this correlation that we talk about.
Correct.
So in the case of Earth and Earth going around the sun with the thread theory, that correlation is found to be very, very, very less, because I have tried so many experiments, and the scientific community regards in general that that the presence of a thread is minute to none, and so that is how the theory gets rejected. So now in the future, I don't know, some genius comes, probes it in a way entirely new, different way, and proves that there actually exists a thread. And so then, that correlation becomes 100% from zero suddenly. So the subjectivity in all of this is this correlation factor. Now, one point of trying to understand science is that it's a never-ending subject, because there are infinite ways to understand a material. There are infinite ways to understand a concept. And so in order to understand anything fully in science, you need to understand it in infinite ways, which is never possible. So it's like a convenient crutch, let's say, where you say, okay, I am happy that I am able to walk. I am limping, and it's a convenient crutch for me to say, okay, I'm happy that I'm walking. Okay, I'm not running. Maybe one day I'll run, but for now I'm walking, and that is good. So it's kind of like that.
So Shravan, you said abstraction is a way of correlating with the physical reality. Actually, physical reality is not abstraction. Abstraction, we are actually correlating abstraction with another abstraction. That's all. Ultimately, we are living in a world of abstraction. Nothing real. Okay, there is a question in YouTube. YouTube.
Yes.
The question is, sir, can you please explain me the formula, how it's an abstraction? That means he is asking about the formula. When you said how formula is an abstraction, he is asking the question. His question is from Sitaraman TS. How formula is an abstraction? Can you please explain?
Right. So all that a formula does is try to connect something physical to something concrete. So it is a way of linking physical experiments, something that you see, something that you touch, to what you think is something concrete, which is mathematics. So scientists have introduced a platform called mathematics where you don't change anything. For example, 1 will always be 1, no matter what happens outside, no matter what happens in the world, 1 will always be 1. The rules of addition will always be 1 plus 1 is equal to 2, no matter what happens outside. So now what we are trying to do over here is trying to fit the physical world into these kind of concreteness. So this is what science is always trying to do. So that is what a formula does. But we know that the outer world is not exactly going to behave like how this formula is. So this is how, so in our ways of understanding physical reality through concrete notions of mathematics, we have tried to create something, we have tried to capture something that goes on in the physical world to something that we can understand. Because what we can understand is things that don't really change. If the definition of 1 always changed with every experiment, there's no way for me to understand 1. If the rules of addition always change, if I say right now 1 plus 1 is 2, next second if I say 1 plus 1 is 3, and then after that I say 1 plus 1 is 4.5, then they'll say this fellow is mad because he doesn't know what addition is. So you are trying to understand something physical using something concrete. And this is how science has always worked, because finally you want to end up with consistent results, and the way to have consistent results is only to describe any physical experiment via something concrete which doesn't change. And that is how formulas come. But the reality is that there's no way to understand this physical world because so many things are changing all the time. And this formula is just a very nice, neat way to satisfy our senses, let's say. I see a ball moving. Yes, the ball is again moving. The ball is again moving. In reality, what has happened to the ball is there are so many atoms that have changed. So many things have changed in the ball. It's not the same ball anymore. The weight has changed. Everything has changed. But you still say, okay, it's kind of the same and it behaves kind of the same way.
So what you're trying to say is, Pranav,
yes,
abstraction is a correlation of physical world with the mental world.
Yes.
Arbitrary definition of physical world with the arbitrary definition of mental world.
Yes.
Which is actually both are again abstractions.
Of course.
Right?
Yes.
Very interesting talk.
Very nice talk, Pranav. In spirituality, we are trying to, all abstractions we are taking as real. So we are trying to get rid of all abstractions. And be without an abstraction, that itself is an abstraction. That's called nirvana, which cannot be spoken of. Nirvana or liberation cannot be abstracted. So science is trying to bring abstraction to model reality. Vedanta is trying to remove the abstraction from reality. Is it true?
Yes. It's bringing one abstraction to remove abstraction.
Abstraction. Okay. Good. Wonderful.
Yeah, wonderful. So any more questions, Ashwini on the YouTube or anywhere?
YouTube question is not there. YouTube question is answered.
There are kids who listen to the talk. Do they have any questions? Did they understand?
Any questions from the audience in Zoom session?
No, sir.
Okay. You understood? Varsha?
Yeah.
Okay. Very good. Anybody else? Okay. So basically, the whole problem in Vedanta, Pranav, we have a big problem of abstraction called I am the self. So we are looking at the entire world into self and not self. This is a very big abstraction and obstruction and distraction also. So getting rid of this concept of self itself is big.
Yes.
Okay. Okay. Thanks, Pranav, for wonderful session and wonderful. It is very, very illuminating.
Yeah. Thanks a lot, Pranav.
Thank you.
Hari Om, Prabhuji.
Bye. Hari Om.
Hari Om,
Bye,
everyone.
Guruji.